To begin this exercise, we first need to set up our equipment to produce short-circuit transfer. The main factors that determine any mode of transfer are as follows: welding voltage, wire feed speed, and the type and mix of shielding gas being used. Each of these factors is selected according to the wire size and material. Please refer to the setting guides given in your learner guide for settings using 0.98 and 1.2 mm wire sizes. In this demonstration, we shall use the 0.98 mm mild steel wire. According to the setting guide for 0.98 mm wire, the voltage required to achieve short-circuit transfer is between 18 and 19 volts, and the wire feed speed between 9 and 10 meters per minute. We will now adjust our equipment accordingly. As the starting point, we shall set the voltage to the lower setting given. On this particular machine, 18 volts is achieved by moving the fine setting controller to the number 2 position. The coarse setting controller remains at the number 1 position. Please note that machines will differ in respect to actual setting positions. Always check the operator's instructions for details on selecting settings. To complete our machine settings, we next select the suggested wire feed speed, and again we will begin by setting to the low figure given, namely 9 meters per minute. For this exercise, you will require a 3 mm mild steel practice plate that has been prepared as previously described, with guidelines scribed onto the surface. Connect the work lead to the lowest inductance tapping and switch your machine on. The first action you need to learn is the striking of an arc. Do not activate the trigger at this time. Simply hold the gun at the correct angle and bring the electrode into contact with the base metal. Now, lift the gun to create a gap of between 1 and 2 millimeters between the electrode and the work. Hold this position and drop your welding visor. Activate the trigger and the arc will start. As soon as the arc is established, a weld pool will form. The gun must be moved along the work steadily, keeping the electrode tip slightly ahead of the center of the weld pool. The size of the weld pool is your main point of reference. The aim is to keep the weld pool diameter constant at about 3 to 4 times larger than the electrode diameter. A very reliable method of assessing whether your weld is going correctly is to listen to the sound of the arc. The sound made by short-circuit transfer, if all is well, is similar to the sound of a piece of cloth being torn. Things are not going right if the sound is erratic and lots of popping occurs. Heavy sparking or spatter, combined with a loud popping sound, is caused when one or more of the following conditions take place: poor electrical connection of the work lead, voltage too low, shielding gas flow too high, and wire protrusion or stick out too long. Correct machine settings and steady manipulation of the welding gun are the key factors for a successful weld. When the end of the run is reached, draw the arc back over the bead for a few centimeters and then release the trigger. Allow the nozzle to remain over the bead so that the post-flow gas will continue the shielding action until the metal cools. An acceptable weld bead will have the following features: an even width of the bead along the full length of the weld, little or no undercutting along the edges. The weld reinforcement should be even and consistent. And looking outside the bead area, you will notice very little spatter, a sure sign that the welding voltage, wire feed speed, and shielding gas flow had been set correctly. Go now and practice the laying of surface beads in your work area under the supervision of your instructor.